Hello friends, welcome to video lecture on fluid mechanics. In the today's session, we'll learn about the numericals on velocity potential function and stream function. So here is the first problem. The velocity potential function phi is given by an expression phi equals to minus xy cube by 3 minus x square plus x cube y divided by 3 plus y square. Find the velocity components in x and y direction so that phi represents a possible case of flow. So first of all, write down here given data phi equals to minus x y cube by 3 minus x square plus x cube y by 3 plus y square. The partial derivatives of phi with respect to x and y are dabba phi by dabba x equals to, you should just differentiate this term with respect to x. So for that, if I differentiate this term with respect to x, derivative of the x is nothing but here 1. So this term will remain as it is. So what's about the derivative of this term? 2x. Okay. So what's about the derivative of this term? 3x square. So y by 3 constant term, that will remain as it is. Okay. So next one, derivative of this term with respect to x becomes here 0 because this is the constant term. Now next one is that you should differentiate this term with respect to y. Now in this case, if we just say if I take the derivative of this one with respect to y, what do we get here? 3xy square in this way divided by this 3 will remain as it is plus next one, derivative of this term with respect to y is the 0. So what's about the next one? X cube y, and derivative of the y with respect to y is 1. So x cube divided by 3 will remain here. And derivative of the y once again here is the y square is nothing but 2y. So once we get these two terms, now can easily get here the values of the u and v. So this relation already we have get from the previous step, and this relation is also with us. So get the value for this one in this way. So minus dabba phi by dabba x is the thing, but this term already, this term available with us. So after multiplying by this minus sign to inside terms, what do you get here? Y cube by 3 plus it minus multiply by minus becomes plus. So here minus minus become plus, 2x will come here, then minus plus, here the minus will occurs here, 3 get cancelled, so x square by y will remain. So this is the relation for the velocity component along the x direction. Okay, so u equals to y square by 3 plus 2x plus minus x square y will come. What's about the velocity component along the y direction? That is v equals to minus dabba phi by dabba y. From this relation, dabba phi by dabba y. So what we get here? Let's substitute the value for dabba phi by dabba y here. So that term already with us. Just substitute here, and minus sign outside of that bracket sign. So minus minus becomes plus here, then minus plus here minus will occur, then minus plus here we can get the minus sign. Now if you look to us here, 3 get cancelled. Okay, just write on the remaining part. So here xy square minus x cube by 3 minus 2y will come here. Okay, this is nothing but the v. Now to check the possible case of the flow, we know that Laplace equation, that is dabba square phi by dabba x square plus dabba square phi by dabba y square equals to 0. Now in this case, d phi by dx and d phi by dy, these two terms already with us. So here from this we can get the dabba square phi by dabba x square. Now if you just differentiate this term with respect to x, so we can get the dabba square phi by dabba x square. So in this case, what's about the derivative of this term with respect to x, as this term is constant? Okay, so here we can get the 0. So derivative of this term minus 2x means here minus 2 only remain. So derivative of the x with respect to x is nothing but 1 here. So derivative of this term 2x into y will come. So 2xy for this one, we can get this value here. Now what's about the next one? Dabba phi by dabba y. For that, already this term with us, dabba phi by dabba y. This term already we have analyzed here. Just substitute this term here and just differentiate this term once again with respect to y. So what we get here? Minus 2xy plus the derivative of this one with respect to y is 0. So what we get here? Derivative of the y is nothing but 1. So 2 will occur here. So what's about the next one? So once we get this term and this term, so add this with this one, means add this term with this one. Okay, and now just see here, minus 2 plus 2xy plus this one minus 2xy plus 2. So minus 2 and plus 2 get cancelled, minus 2xy and plus 2xy get cancelled. So this term must be equal to 0. So therefore Laplace equation is satisfied. Hence phi represents the possible case of flow. So let us discuss about the next problem. The velocity potential function is given by phi equals to phi u into bracket x square minus y square. Calculate the velocity components at the point 4 phi u. So this is the relation with us. Okay. So from this relation, first of all, get the dabba phi by dabba x. So differentiate this term with respect to x. So what we get here? Phi u multiplied by 2 into x. After differentiation of this one, phi u multiplied by y square. So this term becomes actually constant if you just differentiate with respect to x. So what we get here? 0. So in this case, you can get the differentiation of this phi with respect to x in this way, 10x. Similarly, differentiation of phi with respect to y, we can get here minus 2 multiplied by this phi is nothing but the 10y. So this term becomes constant. If I want to differentiate this one, phi u x square with respect to y, you can get the 0. So in this way, you can get the relation for the dabba phi by dabba y equals to minus 10y. But the components of the u and v are given by this equation. We know u equals to minus dabba phi by dabba x. So this term already we get here 10x. Okay. So substitute here minus 10x because this actually term is minus. So minus 10x we can get it here. Then what's about the next one? V equals to minus dabba phi by dabba x. So minus into minus, already the minus sign for this term available with us. So pick up this one as it is and just write here minus 10y. So minus minus become plus. The velocity components at the point 4 and 5, that is at x equals to 4 and y equals to 5. So what we get here? U equals to minus 10x. So what's about this x? X is nothing but here 4, the coordinate of this one along the x direction, that is 4 with us. So u equals to minus 10 multiplied by 4 equals to minus 40 units. What's about the v? For that v, 10y. 10y means here the coordinate of the y with us 5. Just substitute here 5. So 10 multiplied by 5, 50 units. Okay. In this way, you can get the velocity components at the point 4 and 5. U equals to minus 40 units and v equals to 50 units. Let us discuss with the next problem. A stream function is given by psi equals to phi u x minus 6y. Calculate the velocity components and also magnitude and direction of the resultant velocity at any point. So this relation with us, psi equals to phi u x minus 6y. So first of all, get the dabba psi by dabba x. So we need to differentiate this with respect to x. So phi u, differentiation of this x with respect to x is nothing but the 1. So what's about this one? We can get the differentiation for this with respect to x is nothing but the 0. So in this we can get the dabba psi by dabba x equals to 5. Similar case with the next one, dabba psi by dabba y. So differentiation of this term with respect to y, this becomes constant, so here we can get the minus 6. But the velocity components u and v in terms of the stream function are given by this relation. Already we know this relation, u equals to minus dabba psi by dabba y. So what's about this one? This value already with us, minus 6. So minus minus become plus. So 6 units per second, the velocity with us. Now what's about the next one? V equals to dabba psi by dabba x. You should write here. So what's about this term? 5 with us, so 5 units per second. So what's about the resultant velocity? So u with us, v with us. So resultant is nothing but the square root of u square plus v square. So u with us 6, v with us 5. Substitute here and get the value for the resultant velocity. After calculation, we get 7.81 unit per second. Now see how we can get the direction. For that, tan of theta equals to component along the y direction divided by component along the x direction. So what's about this one? V with us 5 and u with us 6. So from this one, after calculation, we get the value for the theta as 39 degree 48 minutes. So this is nothing but the direction of the resultant velocity at any point. Okay, this is nothing but the direction. Let us discuss about the next problem. If for a two-dimensional potential flow, the velocity potential is given by phi equals to x into 2y minus 1, determine the velocity at point p 4 5. Determine also the value of stream function psi at the point p. So this is about the phi equals to x into 2y minus 1. The velocity components in the direction of x and y are, so first of all, just get the value for the u equals to minus dabba phi by dabba x. So what's about this dabba? What's about this phi? Phi already with us here. Just write it here and differentiate this term with respect to x. So what's about the derivative of this one? So this term is constant term and derivative of x with respect to x is nothing but the 1. So this term will remain as it is. So minus 2y minus 1. Okay. So minus sign outside of that bracket. So can write this in this way. Minus minus become plus. So 1 minus 2y can be written here, in this way. Okay. So what's about the next one? V is nothing but the minus dabba phi by dabba y. So what's about this term? You should take the derivative of this term with respect to y. What do you get here? X multiplied by this 2y is nothing but the 2xy, and derivative of this one is nothing but minus, here the minus sign given, that's why the minus 2x will remain. Okay, derivative of the y with respect to y is 1, and derivative of this one x multiplied by 1 is nothing but the x. So derivative of the y, derivative of this x with respect to y is nothing but the 0. That's why minus 2x will only remain here. So at point P 4 5, that is at x equals to 4 and y equals to 5, what's about the u? For that, just substitute the value for the y as 5, substitute the value for here in case of v as here for the x as 4, and do the calculations. So here we can get u equals to 1 minus 2y means 5 here. Okay, so after doing calculation we can get the u equals to minus 9 unit per second. Similar case with the v. So what do we get here? Minus 2 multiplied by x is nothing but here 4. Okay, so what do we get here? Minus 8 units per second. So velocity at the p is nothing but, what do we get here? Minus 9i minus 8j. What's about the resultant of the same? Square root of 9 square plus 8 square. After doing calculation we can get 12.04 units per second. Now what's about the next point? Here you have to calculate the value of the stream function at p. For that we know dabba psi by dabba y equals to minus u. Similar case with the next one, dabba psi by dabba x is nothing but the v. What's about the u term already with us? Is the term with us 1 minus 2y. So minus sign should be given here for the stream function. Okay, so here the minus sign, minus multiply by 1 minus 2y in this way. So what do we get here? 2y minus 1. Similar case with the next one. Daba psi by daba x is nothing but the v. What's about the v? Minus 2x with us. Now integrating the equation number 1 with respect to this one y. So what do we get here? If you look towards the left side and towards the right side, if I take this term towards this side, okay, while taking the integration of this one, you can just say, instead of daba term, we can just say d psi, integration of d psi equals to integration of 2y minus 1 dy. So what we get here, integration of this term is nothing but the psi equals to integration of this term is 2y square by 2 minus 1 dy, means here again the y term will comes into picture. So 2y square by 2 minus y plus integration of the constant term, okay, or constant of the integration. But the constant of integration is not a function of y, but it can be a function of x. So here the two-dimension axis system with us. So here that is not a function of the y, but that function of the x. Let the value of the constant of integration is k, then psi equals to y square minus y. So 2 get cancelled, y square minus y plus the constant of the integration, we can just assume here k, then differentiating this above equation with respect to x. So differentiate this one with respect to x. So what we get here, daba psi by daba x equals to, so with respect to x, this value becomes 0, this term becomes 0, this term becomes 0. So what we get here, daba k by daba x. Now from the equation number 2, we know this daba psi by daba x, this term already with us, minus 2x. So minus 2x with us. Now proceed for the further part, equating the values of daba psi by daba x, we get here daba k by daba x is nothing but the minus 2x. Now integrating this equation, we get here. So if you look towards here, if I keep this one daba k towards one side, and if I take this term towards the another side, and if I take the integration of both the side with respect to x, so what we get, integration of dk is nothing but the k, and integration of this 2x is nothing but here minus x dx is nothing but here. What's about the integration of the x square by 2? So 2 by 2, this get cancelled. What we get here, minus x square. So in this we can get the value for the k. So once we get the value for the k, once again just substitute here and get the clear cut value for this one psi. So here the psi is nothing but the y square minus y plus k, means here minus x square. So here we can get stream function psi at point p 45 equals to, now psi value, this one with us, they substitute the value for the y and x. So what do we get here, 4 units. Let us discuss with the next problem. The stream function of two-dimensional flow is given by psi equals to 2xy. Calculate the velocity at the point p 23. Find the velocity potential function phi. For that, in this way, the value for the psi with us 2xy, and the velocity components u and v in terms of the psi are. So for that, you have to differentiate this term with respect to y, and similarly here differentiate the same term with respect to x. So here in this case we can get the u value, and here we can get the v value. Okay, so u equals to minus daba psi by daba y equals to daba by daba y into, so what's about this psi, 2xy with us. Now you have to take the derivative of this term with respect to y. So what do we get here, minus 2x. So derivative of y with respect to y is 1. So that's why the minus 2x will come here. Similar case with the next one. If I differentiate this term with respect to x, what do we get here, 2y. Now at point p 23, we get u equals to, so you already this relation with us, minus 2x. What's about the x? X with us 2. So substitute here and get the value for the u as minus 4 unit per second. Similarly for the v case, so here 2 multiplied by y, so y with us how much, y is nothing but the 3. So 2 multiplied by 3, we can get 6 units per second. So resultant velocity at P is nothing but the square root of u square plus v square. What's about the u? 4. What's about the v? 6 with us. Substitute here, do the calculation. We can get the value for the resultant velocity at point P is 7.21 units per second. Now get the value for the velocity function, velocity potential function phi. For that we know dava phi by dava x equals to minus u. So what's about the u term? U already with us, minus 2x. These functions actually written with the help of that whatever the relations we have discussed in theory. Okay, so what's about this one? We can get the 2x here, and dava phi by dava y is the about the minus v. So what we get here? 2y. So from both the side minus minus sign with us, so minus minus become plus. So integrating equation number 1. Equation number 1. So what do we get here? Dava phi by dava x equals to 2x. So this dava x comes towards the right side. So what's about this one? Integration of d phi equals to integration of 2x dx. What do we get here? Integration of this term is nothing but the phi, and integration of this term is 2x square by 2. Constant term will comes to the picture. So plus c. So 2 get cancel. What do we get here? X square plus c, where this c is constant, which is independent on x but can be a function of y. Now differentiating this equation number 3 with respect to y. So what do we get here? Dava phi by dava y equals to, so this term, if I take the differentiation of this with respect to y, this term becomes 0. So what do we get here? This should be a function of y. So what do we get here? Dava phi by dava y equals to dava c by dava y. So dava phi by dava y with us how much? Minus 2y. Dava phi by this one minus 2y with us. So automatically what we get here? Therefore dava c by dava y must be equals to minus 2y. Okay. So integrating this term with respect to y. So what do we get here? So integration of dc equals to integration of minus 2y into dy. So if you solve this, what do we get here? C equals to minus integration of y is nothing but the y square divided by 2. To do it cancel, what do we get here? Minus y square. So substituting this value of c in equation number 3. So this is the value of c we get. So substitute this value of the c in equation number 3 and get the value for the phi. So phi with us x square minus y square. Thank you. Hope in the today's lecture problems discussed related with the velocity potential function and stream function cleared you.